Okay, so welcome back everyone. This is going to be part 2 of OLS routine from scratch. So in last part we did up to p-value. Now we are going to continue from that point onwards. I just noticed that I have a typo here. Dependent variable. Right. So let's go on. So in last part we did up to p-value. Let's do confidence intervals. So the formula for confidence interval is beta plus minus the t-statistics t-score into the standard error. So this is just going to be confidence interval lower is equals to beta minus test stat that we just did here into the standard error of that beta. And just let's copy it and make it upper. The upper confidence interval is just going to be beta plus. Okay, now let's get the mean squared errors of the model and the residuals. Model, residuals, and total. So MSE of the residuals is just going to be equals to sigma squared. And then the formula for the sum of squared totals and the sum of squared of the models would change depending on how many covariates we have. If we have one covariate, it will be one formula, and if we have more than one covariate, it will be a different formula. So I'm going to use if statement here. If number of covariates is not equals to 1, which is if we have more than one regressors, then this formula would be applied. Sum of squared total is equals to y minus y bar, summation of y minus y bar squared. And so let's do this. Y minus y bar, and I'm going to reshape this as a 1 by n matrix and do a dot product with the same thing, just n by 1. So this is going to give us a 1 by 1 scalar. And then sum of squares of the model is y hat minus y bar, summation of y hat minus y bar whole square. So this is just going to be y hat minus y bar, and then I'm going to reshape this again as a 1 by n matrix and do a dot product with n by 1. So now we have sum of squares totals and sum of squares of the model. So we can get MSE, mean squared error of the model, is equals to SSM divided by K minus 1, and MSE total is equals to SST divided by n minus 1. But if we have one regressor, then SST is going to be just summation of y square. So there's no subtraction of the mean from it. So it's going to be summation of y square. And then let's do the SSM. SSM is going to be similar as well. Instead of y hat minus y bar, it will be just y hat square. Okay, so this should work. And these formulas would change a bit as well. So MSE the model is going to be SSM, and MSE total is going to be SST divided by just n. So now we have the mean squared errors. Now the remaining parts are the R square and the F statistics. So let's get the R square. So R squared equals to we can use the formula 1 minus SSE divided by SST, or we can also use SSM divided by SST. It's the same thing. And the formula for adjusted R square would change a bit depending on how many covariates we have, that is whether we have one covariate or more than one covariates. So I'm going to use an if statement here. If k is not equals to 1, which is if we have more than one covariate, adjusted R squared is equals to 1 minus n minus 1 multiplied by 1 minus R squared divided by n minus k. And then if we have more than one covariate, there is going to be no n minus 1, just n, and the rest of the formula is going to be same. Alright, now let's calculate the f statistic. It's pretty simple. F stat. So f stat is equals to MSE of the model divided by MSE of residuals. And now let's print out the rest of the information that we have. So I'm going to print out the CI lower, confidence interval, and then confidence interval upper. Okay, so this much can stay together. And then let's print out the other statistics that should be out of the loop. So let's print out the number of observations, regressors, and degrees of freedom. Format, number of observations, and then this should be equals to n. And then number of regressors, they should be equals to k, and degrees of freedom, they should be equals to degrees of freedom that we calculated. Let's add a separator here, and then let's print the remaining statistics, which is the MSEs. Let's start with. Okay, so we can do this. Just copy this one up here, paste it, and change it to MSE residual. This should be equals to MSE residuals, and then MSE of the model, MSE of the model, and then total. Let's use separator again. And now we are remaining is the R squared, adjusted R squared, and the F statistics. So let's print those out as well. So we're going to print the R squared, and then adjusted R squared, and then the F statistic. All right, so this should work. So we have some problem going on here. Nice, okay, so they should do it. So let's use the same code again. This is what we did in part 1. Let's run it again. So now we can see we have more output. We have the number of observations 239, number of regressors 3, degrees of freedom 236. These are the MSEs. Let's match them with that of the stats model. So MSE of the residuals 4536, and here it is, MSE of residual 4536, MSE of model is 2154. So MSE of model is 2.154 plus 10 to the power 9. So this is also matching. The R squared is 0.99975 and adjusted is 0.99974, and Statsmodel model also gives us 0.99975 and 99974. So all of these numbers match, and this function that we just wrote in 2 parts of our video, it replicates all of these things, and it's very helpful to be able to see what formulas are being applied within the package and how each of these numbers are popping up in the output. So that will be all for today. Thank you very much.